I'm now moving on to lesson number 5 in the radicals chapter. And for this lesson, the goal is to simplify radicals when you're given variables with odd or even powers. Now for question number 1, I need to simplify the following radicals when we're given an even power. Okay, so for question number 1, you're going to see some variables, and those variables will have an even power. And for our very first question, I have a to the power of 16. Now, when you take a look at this power, which is 16, for question number 1a, the goal is you're still trying to find pairs, right? So the way you find pairs is you take that power and you divide that by 2, so that you're finding pairs. So 16 divided by 2 is going to be 8. So my final answer for question number 1a is going to be a to the power of 8. So as you can see, a very quick way to do these problems is that if you're given an even power, just take that power and divide by 2, get rid of the radical sign, and you have your final answer. For question number 1b, I have b to the power 26. So 26 divided by 2 is going to be 13. So my final answer is b to the power of 13. Moving on to letter C. For letter C, this time I have 2 different variables. So I have a to the power 4 and b to the power of 50. So all you're doing is you're taking those powers and you're dividing them by 2. So this will be a to the power of 2 and b to the power of 25. And that's your final answer. For letter 1d, I have a to the power 6. So that's going to be a to the power 3 simplified. B to the power 30, take that power and divide by 2. So 30 divided by 2 is going to be 15, so b to the power of 15. And finally for C, I have c to the power 4, so take that 4 and divide it by 2, so c to the power of 2. And there's your final answer for 1D. Okay, let's move on to question number 2, where I need to continue simplifying radicals, and this time I have odd powers. Now, when you're dealing with odd powers, like we have in question 2a, what I like to do is I like to rewrite that x to the power 9 into a product of variables. And when I write this as a product of variables, I want to make sure I have at least an even power in there. And the quickest way to do that is you take your 9 and you minus 1. So 9 minus 1 is going to be 8. So I can rewrite x to the power 9 as x to the power of 8 times x. Okay, so just remember from our powers chapter, if I have x to the power of 8 times x, the single x really has an invisible power 1, right? And when you're multiplying variables with the same base, you just add the powers. So 8 plus 1 is 9. So as you can see, what I'm doing here is I'm taking my original power, x to the power 9, and I'm rewriting it using like two variables, x to the power of 8 and x to the power 1. And that way, that will allow me to use some of the properties that I developed from question number 1. For example, I have an even power here, so that's going to be x to the power of 4. And then over here, I have a single x, so that single x can just remain inside the radical sign. So my final answer is x to the power 4 times root x. Moving on to letter B, I have an odd power again, so let's rewrite that. So let's take my power here, which is x to 11, decrease that by 1, so I have x to the power 10. And then I need to multiply that by a single variable x, because x to the power 10 times x is x to the power of 11. And then since I have an even power here, I can divide that power by 2, which is x to the power 5. And then I have a single x here, and that can remain inside the radical sign. So x to the power 5 times root x. Moving on to letter C, I have a power of 51 here, so let's rewrite that by decreasing the power by 1. So I have x to the power 50 times x. And then x to the power 50 is the same thing as x to the power of 25. And then we have a single x here, so that remains inside the radical sign. And then moving on to letter D. So I have an odd power. Let's rewrite that as x to the power 20, which gives me my even power times x. And x to the 20 times x to the power 20 times the single x is x to the power of 21. Okay, so here's my even power. So that's going to be x to the power of 10. And this is my remainder here. So that that x will remain inside the radical sign. So x to the power 10 times root x. Okay, and for letter E, now I have two variables now. So let's treat the two variables separately here. So I might have two lines here. So I will decrease the 7 by 1. So a to the power 6 times a. And then I have b to the power 5. So that's going to be b to the power of 4 times b. Now, this next step, you don't have to do this next step, but I like to do it anyways. Once you get pretty quick at these, you can skip a lot of these steps. I like to put the powers, the even powers in front. So a to the power 6 times b to the power 4. And then the single variables with no powers, I like to put them at the very end. And then from here, I can just look at my even powers here. A to the power 6 will be a to the power 3. B to the power 4 is b to the power 2. And then I have a and b left over, so those will remain inside the radical sign. So a cubed times b squared times root ab. Okay, let's move on to letter F here. So I have a to the power 3. Let's rewrite that as a to the power 2 times a. And then I have b to the power 5. I will rewrite that as b to the power 4 times b. And then I will use one extra line here to rewrite my problem as a to the power 2, b to the power 4. I like to put the even powers in front. And then I have the a and the b remaining, so I will put that at the very end, a times b. And then from here, that's an even power, so that's going to be a. This is an even power, so that'll be b squared. And then ab will remain inside the radical sign. So a times b squared times root ab. All right, and then we got a few more questions here. A to the power 15 and b to the power 17. Okay, so this will be a to the power of 14 times a, and b to the power 17 will be b to the power of 16 times b. Okay, so I guess I'll skip a step now. So a to the power of 14, if I reduce that, that's going to be a to the power 7. B to the power 16 is going to be b to the power of 8. And then finally, the a and the b, those can remain inside the radical sign as a times b. Okay, let's move on to letter H now. For letter H, I have an odd power here, and I have another odd power there. This x to the power 1 doesn't really do anything, so I can just leave that as a single x. And then I have y squared times y, and for z to the power 5, I have z to the power 4 times z. Then after that, let's find our even powers. So there's my first even power. That will simplify to y. Here's another even power. That's going to simplify to z to the power 2. And then you have this x, y, and z. Those don't have even powers, so those variables can go back inside the radical sign. And that's how you finish off question 2H. Okay, so move on to question number 3. And for question number 3, I have a combination of even and odd powers. Okay, so basically for these kind of problems, I would look for the odd powers first, and I would rewrite the original problem as a squared. And if I have an odd power there, remember, we decrease the power by 1, so b to the power 4 times b. And then from there, we can simplify. So a to the power 2 simplifies to a single a. B to the power 4 simplifies to b squared, and I have a single b left over, so that will be root b. So a times b squared times b. All right, let's move on to question 3b. This time I have an odd power in front, so let's go ahead and rewrite a to the power 5 as a product of two variables. So it'll be a to the power of 4 times a. And since a to b to the power of 8 is an even power, I can just leave it alone like that. All right, after that, let's simplify the even powers. So a to the power 4 is a squared. B to the power 8 is b to the power of 4. And then I have a single a left over, so that's going to be root a. So a to the power 2 times b to the power 4 times root a. Okay, and after a while, you do get the hang of these kind of problems here. So I'll try to speed up this next one here. So this will be a to the power 10 times a times b to the power 10. This part right here will be a to the power of 5. This part here will be b to the power 5. And then I have a single a left over, so that's going to be root a to finish off. For letter D, The only odd power I have for letter D is c to the power 13. So let's just rewrite that as x to the power 6, b to the power 22, and c to the power 13 will be c to the power 12 times c. And then from there, just let's find our even powers. So x to the power of 3, b to the power of 11, and c to the power of 6. And then finally, the single c will go back inside the radical sign. And your final answer is x cubed b to the 11 times c to the power 6 times root c. Okay, we're almost done this video homework guide. The very last question has to deal with simplifying radicals again, but this time we have numbers with even and odd powers. All right, so I'll try to break this up in a different way here. Let's take a look at the b to the power 5. Let's reduce that one first. So I have 100 a to the power 4 and b to the power 5. Since that's an odd power, that'll be b to the power 4 times b. And then we'll look at every single term individually now. So if I have 100, what's the square root of 100? Well, the square root of 100 is 10. A to the power 4 is a squared. B to the power 4 is going to be b squared. And then I have a single b left over, so that will remain back inside the radical. So 10 times a squared times b squared times root b. Okay, for question 4b, I'm dividing a fraction now, so using one of the rules, we can split this up into two individual radicals by writing this as a radical, so that's going to be root a squared times b cubed divided by root 100. So that's step number one. Let's just rewrite this into a fraction of two radicals. And then I can take my b cubed and I can rewrite that as a squared times b to the power 2 times b, because that's an odd power. And then at the very bottom here, the square root of 100, you should know what the square root of 100 is. That's simply going to be 10. And then after that, we can take care of the variables in the numerator. So a to the power 2 is going to be a single a, b to the power 2 is going to be a single b. And then this b right here doesn't have an even power, so that will remain inside the radical sign. And then after that, we just divide by 10, and that is our final answer there. Okay, let's move on to the last two here. Now for the last two here, there are some other numbers like 8 and 32. And from lesson number 1, we did use a tree diagram to break those down. However, I'm going to just do this slightly in a different way here. If I have the number 8, 8 is the same thing as 4 times 2. Now I'm going to write that inside my radical as 4 times 2. And then I have x to the power 3, which I'll write as x squared times x. And then I have a y to the power 8, which I'll leave as y to the power of 8. So I'm going to break down the initial question as 4 times 2 times x squared times x times y to the power of 8. Now after that, ask yourself, what is the square root of 4? Well, the square root of 4 is going to be 2. If I have an even power there, 2 divided by 2 is going to be 1, so that simplifies down to a single x. And then I have y to the power of 8, and 8 divided by 2 is going to be 4, so that's going to be y to the power of 4. And then I have a 2 here and an x here, and those can go back inside the radical sign as 2x. So my final answer is 2x times y to the power 4 times the square root of 2x. Okay, let's move on to the next one here. I've highlighted 32, and one of the reasons why I'm highlighting 32 is, if you think about 32, you have to ask yourself, 32 is going to be, if I break that down, that's the same thing as 8 times 4. And if I take a look at the 8, that's going to be 4 times 2. So my conclusion here is 32 is the same thing as 4 times 4, which is 16, and 16 times 2 is going to be 32. So the way I'm going to rewrite this radical is, I'm going to take my 32 and I'm going to rewrite that as 4 times 4 times 2. Because 4 times 4 is 16, and 16 times 2 is going to be 32. Then I have x to the power of 8, so I'm going to leave that as x to the power of 8. And then I have some odd powers here, so b to the power 9 will be b to the power 8 times b, And c to the 7 is going to be c to the power 6 times c. So I'm going to take the original problem and just break it down into a string of numbers and a string of variables. All right, so let's go ahead and simplify this now. The square root of 4 is 2. The square root of 4 is 2. And then I have x to the power 8, which will be x to the power 4 simplified. B to the power 8 will be b to the power 4 simplified. And then I have another even power here, which will be c to the power of 3. And then ask yourself what's left over. Well, there's a c here, a b there, and there's also this 2 over here at the very end here. So those terms can go back inside the radical as 2 times b times c. And then from there, I can take this 2 and that 2 and multiply them together. So 2 times 2 is going to be 4. And then I can copy out the rest of the terms here. And that right there is your final answer.